Okay, so for number 6, they tell you what e to the x is equal to as a series. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot 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 x to the n over n factorial plus dot dot dot. So we have to write e to the minus x squared using the definition with its series, and that's just substituting negative x squared wherever there is an x. So for part A, we have 1 minus, where there's an x, we substitute negative x squared. We have negative x squared, 1 minus negative x squared, plus we have x to the 4th, so it's x squared, negative x squared, quantity squared divided by 2 factorial. You guys see how that's x to the 4th power? And then we have a minus x to the 6th over 3 factorial plus x to the 8th over 4 factorial plus dot dot dot. Since it's alternating now, we need a negative 1 to the n power times x to the 2n divided by n factorial. Did that make sense? It becomes alternating because some things are to the squared, so they are positive, while that's going to remain a negative. Okay? Then for part B, we have the question, the integral from 0 to 0.1 of 1 minus e to the negative x squared dx. Since we know what e to the negative x squared is, we sub in for that. So then we have the integral from 0 to 0.1 of, it's 1 minus, so then we are subtracting all of a. So then these ones cancel out. So then we have x squared minus x to the 4th, 2 factorial, plus x to the 6th over 3 factorial, minus x to the 8th over 4 factorial, dot dot dot. Yes. And one thing to note that the signs also change since we're subtracting. So we're adding x squared and subtracting x to the 4th 2 alpha, or 2 factorial. Did that make sense? Then it's just taking the integral, and these are all polynomials, so that should be easy. X squared is x cubed over 3. X to the 4th is minus x to the 5th divided by 5 times 3 factorial. Oh, sorry, 2 factorial. Plus x to the 6th, the integral of that is x to the 7th divided by 7 times 3 factorial. And then we have minus x to the 9th divided by 9 times 4 factorial, dot dot dot, going from 0 to 0.1. Did that last part make sense? Are you guys mostly done with your homework? Or? Yeah. Okay. Because this should not be hard. This is just keeping track of the signs. Yeah.
How many of those would you suggest? 4 different terms?
I'd go at least 4 terms. So right here, you should have at least 4. And we started with 5 and we ended with 4. So try to keep 4 there because you never know how many you need to approximate the error. Okay, so if you have from 4 to 5, that's a good range and the answer will be in there. Okay. So subbing in 0.1, we have 0.1 cubed over 3 minus 0.1 to the 5th over 10 plus 0.1 to the 7th over 42. And like for that, we just need to multiply it out. 7 times 3 factorial. 3 factorial is what? 7? 6, right? So 7 times 6 minus 0.1 to the 9. And this, they just kept it as 9 times 4 factorial. Plus, dot, dot, dot. Since we know this is an alternating series, so use alternating series estimation theorem. Does it tell you to put that on? What? So this means since this is going plus, minus, we can use the estimation where we take the next term and see if it's lower than the error. So that's what it means. So I would go ahead and put this on the exam whenever you see this, because that tells them you used the theorem.
So we can show the 3 criteria for that.
No. Well, there aren't really criteria for this. Yeah. You're thinking of the alternating series test with additionally convergence and stuff. But, okay. Are you guys good with this? Copy it down. Okay, so they tell you that the error has to be less than 5 times 10 to the negative 10. So just by guessing and saying, let's look at 2 terms. So using 2 terms, our answer will be approximately 0.1 cubed over 3 minus 0.1 to the 5th over 10. And the next term will be our error, with the error less than 1 over 42 times 10 to the negative 7. Okay, we know that that is greater than that. Because obviously less than 5 times 10 to the negative 10. So looking at 3 terms, our answer will be 0.1 cubed over 3 minus 0.1 to the 5th over 10 plus 0.1 to the 7th over 42 with error less than 0.1 to the 9th over 216. Now trying to simplify that, we get that has to be less than 10 to the negative 9 divided by 2,000. Because since this denominator is bigger, this number has to be smaller than this number, and we made it 2,000 just to be able to simplify the fraction easier. This is equal to 5 times 10 to the negative 12, which is less than 5 times 10 to the negative 10. Now, I'll show you the simplification, but this is something that you should be able to do on the exam. Okay? So, if we are at this part, we have 216, okay? If we made our denominator 2,000, it'd be easier for it to simplify, And we know that our actual fraction has to be smaller than our fraction with 2,000, right? So then it fits the criteria still. So we have 10 to the negative 9. Sorry, 200. 200. Did that make sense? It's 200. We have 10 to the negative 9 divided by 200. Let's try to get it to the other part. So we have 10 to the negative 9 divided by 2. Let's do 1 times 10 to the negative 9. Divided by 2 times 10 to the negative 2, or positive 2. I'm trying to show you how to simplify it to 5 times 10 to the negative 12. Did that make sense? So we're at this part right here, okay? I made the 216 200 because it's just easier to work with it, okay? And we know we can change it to 200 because our original fraction is still smaller than that, okay? Since 216 is greater than 200. Yeah? It's just working with the math and since you don't have a calculator. 200 is the same thing as 2 times 10 to the 10 squared, right? Scientific notation. 10 to the negative 9 is the same thing as 1 times 10 to the negative 9. 1 divided by 2. So we have 1/2 times 10 to the negative 11. That's equal to 5 times 10 to the negative 12. Because 1/2 is 0.5 times 10 to the positive 2. We bring it up, which is minus 2. We have 10 to the negative 11. 0.5 times 10 to the negative 11. We move the decimal to the right. That's the same thing as 5 times 10 to the negative 12. Okay? And we know that that is definitely lower than 5 times 10 to the negative 10. Yeah.
Why can't we just have like 10 to the 9 in the original denominator and the 216? So we move the decimal place.
You want to bring it down?
2.16 times 10 to the negative.
Is that what you're talking about?
No.
That's how you would do it?
That's how I do it. It's just how I
Yeah.
see it.
There's different ways to see it, but the thing is you should be able to do the math and get from here to here. Okay? Did I lose most of you guys?
Yes.
Can we not just say that that is less than 5 to the 5 times 10 to the negative 10?
No, you have to show at least the step.
0.1 to the 9th power is going to be 10 to the negative.
Well, what if this was just a 2 or something? It's not, but
I know.
it's like you have to show it so that it's close enough where you can definitely see it. Like obviously this is going to be lower than that, right? But they still want you to show the steps where these can be similarly compared. So you might, in some problems, you might end up with a 2 times 10 to the negative 12. But we still know it's lower because the error they want is 10 to the negative 10. Did that make sense? Okay. So just summarizing it, you guys understand why we couldn't use 2 terms, right? Because this now, just by looking at it, is obviously greater than 5 times 10 to the negative 10. The 40 in the denominator is not going to move it 3 decimal places. Okay? So we go to 3 terms, and we find by simplifying it 5 times 10 to the negative 12, and that is lower than the error that they want. So we can stop right there. We don't have to simplify, since they say they do not simplify.
So when we did using the 3 terms, you don't have to actually work out the value.
It depends on the question.
Okay.
They might not. So for this one, they say, do not attempt to simplify your integral approximation. So then it's fine. But if they don't state that, you do need to solve it. It means you don't need to solve that out and solve this out and such. Because they say leave it as a sum of terms. So it's like what you have here is good enough. And you obviously need to show all of this. So any questions on that problem? It's not a hard problem, it's just working with the algebra. Yeah.
So when you're doing stuff with the error, you always want to do like one that's less than one.
You want to find a fraction with that's going to make the amount of difference which is less than the error that they want. Okay? So we can have this much error in our calculation. So by adding this fourth term, it's not going to change our answer by, an amount that matters. So that's what they want. So that's why like our calculators calculate to like some decimal point, which is, huge, but it ultimately doesn't matter afterwards. Okay. You guys good to move on? So our f of x for number 7 was natural log of x. So our f prime is 1 over x. F double prime, negative 1 over x squared. F triple prime, 2 over x cubed. F to the 4th. They stated as negative 3 factorial over x to the 4th. And then f to the 5th, 4 factorial over x to the 5th. Did you all get that? Or do you want me to go over them? That's just doing the derivative continuously. And then you realize it's 3 factorial, 4 factorial, 5 factorial, dot, dot. So then when we have f of 1, we get 0. F prime of 1, we get 1. F double prime of 1, we get a negative 1. F triple prime of 1, we get a 2. F fourth prime, we get negative 3 factorial. And to the 5th, they just wanted to do it prime of c. So we have 4 factorial times c to the 5th. So that chart, you guys should have no problem with that. That's worth 4 points. Yeah.
Will we get points taken off if we don't recognize that it's 3 factorial, 4 factorial?
You really shouldn't. But in the problem, when you do the math and stuff, it's always easier to recognize factorials. So are you guys good with this? The last one, you add a c because it's f5 prime of c. So then for part B, we have to write the Taylor series. So we will have for till f4 of x. So then that's going to equal to f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 over 2 factorial times x minus 1 squared plus f triple prime of 1 divided by 3 factorial times x minus 1 cubed plus f to the fourth prime of 1 divided by 9 factorial, divided by 4 factorial times x minus 1. That's just the Taylor series. Are you guys good with that? What? Yeah, we're not done with it.
Oh.
You have to show 5 times.
Oh, okay.
You have to show it to the fourth time, because they say 4 right there. So f of 1 was 0. So 0 plus x minus 1 minus the quantity of x minus 1 squared divided by 2 plus 2 times 3 factorial. Divided by 3 factorial times x minus 1 quantity cubed minus 3 factorial over 4 factorial times x minus 1 to the 4th power. And if you simplify that, we have x minus 1 minus x minus 1 quantity squared divided by 2 plus x minus 1 quantity cubed divided by 3 minus x minus 1 quantity to the 4th divided by 4. Did that all make sense? That's worth 4 points as well. So you guys should really get all those points. Are you guys good to go to part C? So this is where people will lose points. So the remainder with the 5th prime of x comma 1 is equal to, we have f of 5 prime with c times x minus 1 to the 5th divided by 5. Divided by 5 prime. This is like the next term here. And we're doing it with c. So we found f to the 5 prime of c to be 4 factorial divided by c to the 5th. So and then we have times x minus 1 to the 5 divided by 5 factorial. And that's equal to x minus 1 to the 5th divided by 5 times c to the 5th. Because that goes away and we're left with a 5. And then it asks us for the restrictions on c. And that's always xo divided by x. So we have 1 less than c less than x, or x less than c less than 1. You could also say c is between x and 1.
Are we going to be given the formula for the remainder?
Nope. It's just the next term with a 5 prime or 6 prime, whatever you have of c. Yeah.
Should the remainder be R sub 4 because the formula has 1. So the remainder of 4 would be like R4, and then it would be like f fifth derivative of c x minus 1 over x minus 1 fifth.
Are you asking if we should go one more with this?
No, like wouldn't it be different? Like just it says R5 there, shouldn't that be a 4, or is
No, it should be a 5. Because it's the 5th term being a remainder. That's how they show it on the old exam with that notation. So any questions on this part? Yeah.
Is that all you write?
For C, yes. So this wasn't too bad, right? It's just FFC, once you have that, but you do need to simplify it right there, okay? These are the restrictions on C, and this is how you like to normally do it. XO for us is 1, so C is between X and 1. So C, X could be a number greater than 1, so it could be like this, or X could be less than 1, so it could be like that. One second. Because our XO is 1. It could have been 2, so then we'd have X minus 2 throughout the whole thing. So did this part make sense? Or can you replicate it on exam? Because it's just, essentially you have a smallish formula and you're plugging in parts. I'm going to erase all this. So now we have to estimate the maximum error with our limits between 0.9 less than or equal to x, less than or equal to 1. And we know C has to be between x and 1. So the actual value of r to the 5th, x comma 1, has to be less than or equal to. Since we want the maximum value, so let me rewrite this. Since we want the maximum value, we want our C to be the lowest number possible and our x to be the greatest, or our denominator to be the lowest number possible and our numerator to be the greatest number possible, okay? And then you just have to work with what you're given. So in this case, and they don't have to be the same values, x and c, okay? So in this case, if we want our numerator to be the greatest value possible, it doesn't really matter. We could do 0.9 minus 1.1 minus 1 or 1.1 minus 0.9. In this problem, it doesn't matter. But you choose the one that makes the numerator the biggest. So we can do 0.9 minus 1 to the 5th. And since it's an absolute value, the sign doesn't matter. Divided by 5. We want our denominator to be the lowest. Okay? So we could do 0.9 or 1.1, but you have to remember you could also do 1. Okay? In this case, 0.9 would make the denominator the lowest. So we use 0.9 to the 5th. That's equal to 0.1 to the 5th divided by 5 times 0.9 to the 5th, which is equal to 1 over 5 times 9 to the 5th. And we can leave our answer right here. Did that make sense? I'll show you guys with one more example. Yeah. Less than or equal. Did that make sense with trying to keep the denominator the lowest and the numerator the biggest? I mean, you might not even have a fraction on your exam, but you use the values that make it the biggest. So if you have so this one I'm just gonna say 4 times x comma pi over 8. So you could have crazy things like this. And we had found, say, is equal to 32 divided by 5 factorial times cosine of 2c times x minus pi over 8 to the fifth. You had found your r value to be this formula. Calm down. We have 0 is less than x less than pi over 8. Pi over 6. Is that a 6 or no? Keep it a pi over 6 right there. And our c value is between x and pi over 8. We have to figure out what we can plug in to make this the maximum error, okay? Cosine will be maximum with 0 or pi over 6? With 0, because then cosine is equal to 1. Okay? So we'll choose 0 for our c value. So then we have a 1 right there. How can we make this number the maximum value? By choosing 0 for x. So then we have a, what? It's the actual value. So then we have 0 minus pi over 8 quantity to the 5th power. And then you simplify that.
Under 0 is less than x, less than pi over 6 x. What?
These are the limits for c. This is the and sign.
X and pi over 8.
Did this problem make sense? Like the point that I'm trying to show you is that we could have a 0 for c because they told us x was between this. But if c was in the denominator, we couldn't use 0 for it, right? So then we have to, our values don't even have to come from our endpoints. They could be in them, between them as well, okay? Just to make sure that the error is the biggest possible. So any questions on that?
Yeah, I'm a little confused about the remainder on why you put it as 5, because in your notes they put them as like Rn equals.
Are you talking about that one?
Yeah, like the one before it. It would have been 6. According to that. Because they have like Rn x,
Yeah.
x of 0 equals Fn plus 1 times the plus 1.
Looking at,
That's kind of
it should be a 4.
Will they give that?
Yeah.
Okay.
So they made a mistake when writing the old exam. But just make sure that we found our f of 4. So I erased it, but we found that for part B, right? With the 4, so this would be the next term. So they wrote the exam wrong, but what you guys have seen is that should be a 4. So any questions on this part though? How you have to look at the limits and try to find the biggest. Okay? Yeah. Are you guys good to move on? Okay. We are moving on then. look over a problem where you have trigonometry with the remainder from the homework, because that's more likely what will be on the exam. So for this problem, we're given the binomial series. And then dot, dot, dot. I already told you guys what it is. So we have to approximate 1.2 to the cubed root with error less than 5 times 10 to the negative 4. And it does say using the least number of terms. So that means you can't just go and choose the 5th term, you know, and be happy with that. You have to show why you chose however many you did. So looking at this is equal to 1 plus 0.2 to the 1/3 power. So we turned what we were given into a form with that series. So then that's equal to 1 plus 1/3 times 0.2 minus m times m minus 1. So it's minus, what do they have?
It's a plus and then it would be a negative 2/3.
Yeah. Did I write that wrong? No, that should be a plus. But they have a minus here. They have minus 2 over 9 times 0.2 quantity squared divided by 2 factorial. Is that right? Because-
1/3 minus 1 is going to be a negative number. So that negative is
Yep. Oh. So this would be did I do that right?
1/3.
Yeah. Good. Plus 10 over 27 times 0.2 cubed divided by 3 factorial minus 80 over 81 times 0.2 to the 4th over 4 factorial. So how many terms you should go? I highly doubt you would need to go that far. Like, you know, here. I would at least do the first 4. Okay?
Where are you getting the fraction?
Because it's divided by 2 factorial, and then the next one is divided by 3 factorial, I believe. What?
It's 1/3.
Oh, well, this is 1/3 times 2/3, negative 2/3. So you get negative 2 nines. Is that what you're asking?
Yeah, how do you do it?
How do I get the next one? Well, on the exam that I posted online, they tell you the pattern. So the next part is m times n minus 1 times n minus 2 divided by 3 factorial times x cubed. So you just fill in. So this is 1/3 times negative 2/3. So this is 1/3 minus 2. So that's minus what? 6 over 3 minus 5/3. Did that make sense? And then, so here's what I would say. It's highly unlikely you would need to use the 5th term to find the error, but it's always safe to go to 5 in every problem. Okay? Even in the problems that we did before with e to the minus x squared, it's always safe to go to the fifth fifth term, so that you're always safe. You know they're not going to ask you further than that. Okay? So for this one, you could have stopped at the 4th, because you actually don't need to know the 4th term, but we'll use it. Okay. So we know, since this is alternating, we can use the alternating series theorem. Alternating series after first term. So we use the alternating series estimation theorem.
They give us that formula for like.
Yeah, the binomial formula. Yeah. Okay. So using two terms, our answer will be 1 plus 2 over 30, with error at the next term being less than 0.2 quantity squared over 9. Did that make sense? The 2 factorial and the 2 cancel. So our term is 0.2 squared over 9. That's equal to 0.04 over 9. And we know that just by looking at it, that is greater than 5 times 10 to the negative 4.
Is there a reason they didn't change 0.2 to 1?
You could do whichever to simplify it. Okay? Just so as long as you can show it. And this was worth 2 points. Okay? They wanted you to show that you needed to use the least amount. Okay? So it's best to start with 2, then go to 3. Then if that doesn't work, you go to 4. Because then you can definitely show that that's the least amount to have the error. Okay? So then looking at 3 terms, our answer will be 1 plus 2 over 30 minus 4 over 900. This simplifies to 4 over 900, with error being less than 0.2 cubed is 0.08. Actually do all the math. Okay. So we have 0.08 divided by 27.6. 3 factorial is what? 6, right? They actually do the math. And then that is equal 0.08 divided by 162, which is less than, oh, sorry, this is 27 times 6. There we go. Did that make sense? 0.2 cubed is 0.2 cubed times 10 is 0.08 divided by 27 times 6. So you have this fraction. That's easily doable. That's less than, just by approximating, 0.08 divided by 100. No, let's just 3160. We'll go with 160. Okay. Then that is equal to 8 over 16 times 10 to the negative 3. Did that make sense? The top is 8 times 10 to the negative 2. Bottom is 16 times 10 to the times 10 So if we have 8 over 16, we have 10 times 10 to the negative 3. That's equal to 0.5. Or they just say that's equal to 5 times 10 to the negative 4, which is what our error was supposed to be. So then we found the fourth term to be equal to that error, so we're good. Any questions on this part? We're still not done. They don't tell us to do not simplify, so we actually do need to add up these 3 terms. Okay? Yeah. It has to be, it can be equal to it. It just can't be greater than it. And like, you won't get a problem where it's going to be equal to it. It just happened to be in this. Yeah.
I get why you use 160, but we can use like any value.
Yeah. Yeah. But if you use any value less than that, you'll get an answer greater than this. Like it just happened to be exact. Normally you won't even be close enough like this. But we still need to add up these values, which I will do on this. So if we were to add them, it's equal to 900 plus 60 minus 4 divided by 900 equal to 956 divided by 900 equal to 239 divided by 225. So this would also be part of your answer. So this exam will be long. And what? Yeah. Every exam is painful. Any questions on this problem? Like, I don't find that these problems are hard. They're just have a lot of algebra to them. Okay? There's a lot of adding and working with fractions and stuff. So the math isn't hard, but make sure you don't get confused with the algebra. So can I move on, or yeah? All right, guys, we're almost done. The last one is a recurrence relationship. We have 3 times y prime plus 2xy equals 0. We have to use the power stuff with y equal to the series k equal to 0 going to infinity of a sub k times x to the k, where a sub k, we have to list wherever a sub k equals to 0 as well. So these also are not hard, okay? They just require like knowing the signs and everything, okay? Just being careful through them and knowing the steps. So the first step is to substitute where we have y prime and y. So we have 3 times, if this is our y prime is the derivative of that. So that's equal to the summation of k equals to 0 going to infinity of a sub k times k times x times k minus 1.
Are we allowed to leave the 3 as well? Like with the y prime vehicles, like our first, like our highest order of magnitude should be like 1.
Something else.
You can leave it.
That's pretty. Maybe 20 something.
That could be on the exam.
Oh.
This problem doesn't ask for that.
Oh, yeah, they should go for it.
Okay. So we can leave it in this problem. But go over that, because that's not on the exam, practice exam. That could be on your actual exam. So we have 3 times y prime, which is the summation of k equal to 0 going to infinity of 3 times a sub k times x to the n minus 1. And that should be a k minus 1. Plus 2 times x times the summation of k equal to 0 going to infinity of a sub k times x to the k power equal to 0. Did that make sense? We just substituted y prime and y. Now we just have, we go and simplify. So therefore, the summation of k equal to 0 going to infinity, we have 3 times k times a sub k times x to the k minus 1 plus summation k equal to 0 going to infinity of 2 times a sub k times x to the k plus 1. We get k plus 1 because we have an x on the outside. That adds a plus 1 power. Okay? And you have to realize that since k plus 1 is greater, we have k plus 1 leads k minus 1. It leads it by how many terms? 2. So we have to take the first 2 terms out and then replace k with k plus 2.
This class today, they have the coefficients on the outside of the series.
It doesn't matter. So therefore, we can do 0, which is k equal to 0, plus 3 times a1 times x to the 0, which is k equal to 1, plus the summation of k equal to 2 going to infinity of 3 times k times a to the k x to the k minus 1, plus the summation of k equal to 0 going to infinity times 2 a to the k x to the k plus 1. We replace k with k what? K plus 2. So we can say 3 times a1 plus the summation of k equal to 0 going to infinity of 3 times k plus 2 times a to the k plus 2 times x to the k. Because this would be k plus 2 minus 1. So we have k plus 1 here. Don't forget to make this a to the k plus 2 also. Don't just leave it as a to the k. And then the second part is summation of k equal to 0 going to infinity 2 times a to the k now. Just a to the k times x to the k plus 1.
Where did your x and 0 go from your first step?
X to the 0 is what?
So you can just get rid of it, you don't have to.
I mean, it's just a 1. And then we can combine the summations into one. So we have 3 a to the 1 plus the summation of k equal to 0 going to infinity of 3 times k plus 2 times a to the k plus 2. That quantity plus 2 times a to the k and quantity times x to the k plus 1. Okay? Now you have to realize that this 0 means this 0 plus 0 times x to the 0 plus 0 times x to the 1 dot dot dot. So then any term here with an x component, or like this says x to the 0, all of them, each part equals a 0. Okay? And that helps us simplify. So then, looking at that, we know our A1 is equal to 0. And this quantity from here to here is equal to 0. Okay? So then we can solve for that part. So then a to the k plus 2 is equal to minus 2 times a sub k divided by 3 times k plus 2. Okay? And showing both of these is, that's our recurrence relationship. And that's where, like this part is worth 2 points. But the majority of the points come from the work getting to it. Okay? And then the problem also asks us where a sub k equals to 0. We know a sub 1 is equal to 0. And just by looking at it, and if you were plugging in a 1 here, a sub 3 would be equal to 0, and a sub 5 then would be equal to 0. So dot dot dot. Any a sub odd would be equal to 0. Does that make sense? Since a sub 1 is equal to 0 and we plugged in to find a sub 3, we get that equal to 0. If we plugged in a sub 3 in here to get a sub 5, because it'd be 3 plus 2, that's going to equal 0. Yeah.
If that whole thing is not equal to 0, you just equate coefficients the same way
It will be equal to 0.
all the time.
Yeah, because you'll be given a function that's going to like 3y prime plus 2xy equal to 0. Did this process make sense? So the only thing hard about this is realizing all the process things. Then on your test, you may have to find k equal to 1 and, sorry, you have to find, say, a sub 2, a sub 3, a sub 4. And that just involves substituting the parts in to find that. So if we were to find a sub 2, it's not asking us, but we'd have minus 2 times a sub 0 divided by 3 times 0 plus 2. So our answer would be a negative 2, or actually a negative a sub o divided by 3. That would be our a sub 2 value. So you, on your exam, you may have to find a sub 2 and a sub 3 and a sub 4 or something. But once you have this equation, that's not hard. Then it's just plugging in the different things. So any questions on this? So the beginning, you find y prime by taking the derivative of the summation You plug in y prime and y, you find which is your leading, and then you combine them in. So any questions on this problem or anything? Yeah.
Yeah, that very last part, we went from -2AO to -AO. Can you explain that a little bit better?
Yeah, because this is, in the denominator, I have 3 times 0 plus 2. The 2's cancel out. So it's -1/3 times AO. So yeah, like, the math is going to be what's going to trip you guys up on this new section. Okay? So if you have to go slow, go slower so that you can get the most points. Don't always try to rush everything. And if you don't remember a problem, just move on and finish the exam. Any other questions? No? Okay.